Hey everyone, welcome back to the second episode in our beginner friendly series on large language models. In the last video, we had a brief introduction to large language models where we explored what they are, why they are powerful, and what makes them large in the first place. We also unpacked a few important terms like tokens, parameters, etc., the concepts that will come up often as we go deeper. But today, we are going hands on. We'll run our very first text generation using an open source model from Hugging Face, and I'll explain every single line so even if you are totally new, you will be able to follow along. Our model of choice is Distill GPT-2, a streamlined version of OpenAI's GPT-2. Developed by Hugging Face, Distill GPT-2 is designed to be faster and more efficient, boasting 82 million parameters compared to GPT-2's 124 million. This makes it an excellent option for those working with limited computational resources or seeking quicker inference times. Alright, so let's start off by importing the essential libraries that we'll be using in this notebook. We are going to use the Transformers library provided by Hugging Face, which is like the Swiss Army knife for working with pre-trained language models. And to be specific, we are going to import two modules from the Transformers library, namely Auto Tokenizer and Auto Model for Causal LM. So let's begin. We'll first write from Transformers import the first module, which is Auto Tokenizer, and Auto Model for Causal LM. So these are the two modules that we want to import. Now, Auto Tokenizer is the module that helps us to convert human readable text into something the model understands called tokens. And we've already covered what are tokens in our previous videos. They are nothing but chunks of text, and one particular word can be equivalent to one token, or a word can be divided into multiple tokens. So this is how it goes. Now, this module is smart enough to automatically pick the right tokenizer for the model that we want to use. Then we have the Auto Model for Causal LM module. This loads a pre-trained model that's suited for causal language modeling, meaning predicting the next word given the previous words. This is perfect for tasks like story generation, chat, or completing a sentence. In addition to these two modules, we also want to import Torch. Now, we all know that PyTorch is one of the most popular deep learning libraries. It runs everything under the hood, from tensors to GPU acceleration. When we encode text, pass it to the model, and get outputs, PyTorch is what makes it all work efficiently behind the scenes. So in short, Transformers gives us powerful pre-trained models, and Torch gives us the computation engine to run them. With these in place, we are all set to start working with our model. So we'll just run this cell and load the necessary libraries. So now that we have the tools at our disposal, it's now the time to load the actual model we'll be working with. And to do that, we first define the model that we want to use. So for that, I'll create a variable called model name, and to it we'll assign the name of the model that we want to use, which is Distill GPT-2. Now, as the name suggests, this is a distilled version of OpenAI's GPT-2, which is smaller and faster and perfect for our demonstration. So now that we have defined the name of the model that we want to use, the next step is to load the tokenizer. So for that, we are going to create another variable called tokenizer, and using the auto tokenizer module or class that we have imported earlier, we'll assign it the tokenizer for a particular model. So from pre-trained, we'll pass in the name of the model. Now remember, a tokenizer breaks down the text into tokens that the model understands. And here we are using the auto tokenizer class because it intelligently figures out the right tokenizer settings based on the model name we give it. So for example, to this auto tokenizer class, we are saying, please grab the right tokenizer for distill GPT-2 and store it in this variable called tokenizer. Now that we have loaded the tokenizer, the next step is to load the model itself. So for that, we'll again define a variable called model, and using the auto model for causal LM class, we are going to call the model. So again, these are pre-trained open source models. So we are using the from pre-trained pipeline in here. And to this, we are going to pass in the name of the model that we have defined earlier. So here we have loaded the actual language model, that is distill GPT-2, using auto model for causal LM class. Now, causal LM stands for causal language modeling, which means the model predicts the next word based only on the previous ones, like completing a story or generating text word by word. Just like with the tokenizer, we give it the model name and Hugging Face take care of the rest, downloading, loading weights, and preparing it for inference. So now with these 3 lines, we have picked the model we wanted, loaded the right tokenizer, and loaded the pre-trained model ready for text generation. So we'll run this cell. Now the tokenizer and the model have been loaded, and we are now ready to start feeding it prompts and see what it can generate. So our next step is to define the prompt. For that, we'll set a prompt. So we'll create a variable called prompt and we'll pass in our prompt, which is once upon a time. So this is the seed text from which our model will generate the continuation. We'll just run this cell so that this particular text is assigned to the prompt. And then we move towards the next step, which is encoding a prompt using the tokenizer that we have loaded. Now, to do that, we'll define another variable called inputs and we'll use the tokenizer that we defined earlier here. Alright, so to this tokenizer, we'll pass in the prompt so that it is broken down into tokens, and we'll also specify the return tensors parameter and pass it the option PT. So basically what we are doing here is we are indicating that we want PyTorch tensors to be generated for the tokens. Alright, so this line of code is used to encode a prompt so that the model can understand it better. Now we'll run this cell. So now we had defined a prompt and we have also encoded it, and we can look it like this. So currently the inputs are in the form of tensor, basically PyTorch tensors. Alright, now the next step is to generate the output. Now to do that, we'll create a variable called output so that it will store the result, and we will call in the model that we have defined earlier here. So now using this model, we are going to call the generate method, and to it we'll pass in the inputs like this, and we'll also specify the max length to be, let's say, 100. Alright, so max length here sets the maximum length of the generated text to 100 tokens. Alright, so please pay attention that it is 100 tokens and not 100 words. Now we have set the output as well. We'll run this cell also. So now the output is being generated. Basically to the model we have passed the inputs. Inputs are nothing but the encoded form of a prompt, and we've also passed it an instruction that the length of the generated output should not exceed 100 tokens. Alright, so now we have run this cell as well. And finally we come to the step where we decode the generated tokens back into human readable text using the tokenizer's decode method. Alright, so here is how we are going to go about that. We'll create a variable called generated output. We'll use the tokenizer. Alright, then we'll use its decode method, and to this decode method we'll pass the outputs. Okay, so let's just take a look at outputs also. So this is the output. This is in the form of tensors, and we are passing in the output to the decode method, and then we are going to set the skip special tokens to true. Alright, to remove any special tokens if there are any. So using this line of code, we are actually decoding the generated output. Alright, now let's just print the generated output also. Okay, and now we'll just run this cell. So this is the generated output, and we can see that we started with a prompt which only had this portion of text, which is once upon a time, and then we use the model to generate the following text, and it comes out like this. So it says, once upon a time of war, the United States was the only country in the world to have a military presence. And then we see that it keeps repeating itself. I mean, the same sentence over and over again, that the United States was the only country in the world to have a military presence. Now this is happening because the model seems to be generating the sentence over and over again in a loop. So to avoid this, we can pass another parameter to the model, which is repetition penalty, and we can set it as 1.2. Now this parameter helps to discourage the model from generating the phrases or words over and over again, and when set above 1, it penalizes the tokens that have already been generated, making the model less likely to repeat them. This is essentially useful for smaller models like Distill GPT-2, which are more prone to looping output since they are not so large. I mean, their number of parameters is less as compared to other models which are robust. So to deal with situations like these, we make use of the repetition penalty parameter. So let's see, I'm again passing the repetition penalty to the model. The cell has run. Now we'll just run this again. Alright, now we can see that there are some other sentences now. I mean, it's not repeating itself. As you can see, once upon a time of war, the United States was in danger. The Soviet Union had been on its way to become an ally, and so on. Alright, so we see now that there are no repetitions of the sentences over and over again. So you can think of repetition penalty like a conversation rule in a group discussion. Imagine you are in a classroom discussion, and every time someone repeats themselves, the teacher gives them a gentle nudge to say something new instead of echoing the same point. So in model terms, if a word or phrase has already been used, repetition penalty tells the model, hey, you have said that already, try something else. So this encourages variety and prevents the conversation from getting stuck in a loop. So this is the role of repetition penalty as a parameter which is passed to the model while generating the output. So this encourages variety and prevents the conversation from getting stuck in a loop. So this was the role of repetition penalty. Now let us take a look at another parameter called temperature. Now this particular parameter adjusts the randomness of model's predictions, and the values for this parameter ranges from 0 to 1. So a higher temperature value, for example 1.0, makes the output more diverse and creative, while a lower value, for example 0.2 or 0.3, results in more focused and deterministic responses. So by default, the value of the temperature parameter is set to 1.0. So now we'll just try it out with 0.7. Alright. to bring a little bit difference in the output that is generated. Now, you can think of temperature as the spice level in a dish. A higher temperature adds more spice, leading to varied and unexpected flavors, whereas a lower temperature keeps things mild and predictable. So here in this example, we are setting the temperature to 0.7, which would discourage the model to produce more diverse and imaginative text as it would have when the temperature would have been 1.0. Alright, because we have decreased the value of temperature in here. Now, there is one more parameter called top P. These are the parameters which you will find with almost all of the LLMs out there. So that is why I feel that we should discuss it here only, even though it may not reflect that much change in this particular model because this is a relatively very small model. Alright. So the top P parameter, also known as nucleus sampling, controls the diversity of the output by limiting the section of next word candidates to a subset whose cumulative probability mass exceeds the threshold P. So you can imagine you are choosing words from a bag where each word has a probability weight. So we are going to set top P as 0.9, which means we are only going to consider the top P words that collectively make up 90% of the probability mass, ensuring relevance while allowing for some creativity. The default value for this parameter is also 1.0. So basically, we are currently decreasing it to 0.9 in this example. So now that we have set the values for these two parameters, there's one more important piece we need to include for these to actually take effect, and that is the doSample parameter. By default, the model uses what's called greedy decoding, which always picks the most likely word, making the output very predictable. But if we want to see the effect of our creativity controls like temperature and top P, we need to tell the model to sample from the possible next words instead. So let's just try and see, even after setting these two parameters, are we going to see any change in the result that is generated. So I'm going to run these cells. And we can see that even though we have set the temperature and top P parameters, the output did not change or vary at all. So now let's try to set the doSample parameter. So it should be made true and its default value is false. So this particular parameter switches the model into sampling mode, allowing it to actually consider different possibilities based on the level of creativity and diversity we just defined through the temperature and top P parameters. So this particular parameter tells the model that okay, don't just go with the safest answer, try mixing it up a little. And only then will the temperature and top P start doing their magic. So let's again run these cells and now check out the output. Now, after setting the doSample parameter as true, we can see that the generated output has changed by a lot. Alright, it's entirely something different from what we had earlier. So setting this parameter as true introduces randomness into the generation process, allowing for more varied and creative outputs. And we just saw how. So this is how it works. Adjusting temperature and top P allows you to steer the model's output towards your desired level of creativity and determinism. So you can experiment with different values to see how the model's responses change, and this hands-on approach will give you a deeper understanding of how these parameters influence text generation. But yeah, do remember that in order to see the effect of temperature and top P, you need to set doSample as true because its default value is always set as false. Also, I would like to mention that you can try other models as well. You can just change the model ID here. Here we are using Distill GPT-2. You can make it GPT-2 or Mistral or any other open source model which is available in Hugging Face. and carry out these steps to generate your text. Also, currently in this example, we have used a very open-ended prompt like once upon a time, but we can even make it a little bit more targeted. Let's see how. So here we'll change the prompt to something else. So now the prompt is, once upon a time in a quiet village, a young inventor named Eli. So like it's a half-baked prompt at the moment. We just want to generate the rest of the text which would be in line with this particular prompt. So by the means of this prompt, we are letting the model know that the setting of this particular story or the text which we have provided as a prompt is in a village, and it is about a young man named Eli who is an inventor. So now we'll just set the prompt, we'll convert it into tokens, and then here this is where we are going to get the output, which would be again tokenized, and we'll need to decode it. Let's just remove these settings here to see how it would generate the result. So you can see now that the generated output is in line with the queue that we have already provided to the model. It starts as, once upon a time in a quiet village, a young inventor named Eli was born, which is the queue that we have given in the prompt itself. And after that, the model has taken up from there, and it says that he had been working on the first prototype of an electric car that would be able to drive around and make it into his home state for sale at auction and so on. So basically it gets the queue and it's giving an appropriate output according to that as well. Now let's just try adding the temperature settings here. Once again, we'll set it to 0.9, we can make it 0.8. Like you can try out different combinations at this point. All right, and then we'll generate the output again. And here, once upon a time in a quiet village, a young inventor named Eli has become the first man to create an electrical device. So you can see that now again it is following from the same queue, but the response is different this time around. So this is how we can play around with temperature and top P parameters to get creative outputs like these. So in this tutorial, we have imported necessary libraries, loaded a pre-trained model and tokenizer. We defined a prompt for text generation and generated text using specific parameters to control creativity and coherence. And we decoded and displayed the generated text. And we have seen how we can play around with temperature and entropy, and how even the prompt that we give the model shapes the output. So this process showcased the power and flexibility of Hugging Face's Transformers library, making it accessible even for beginners to experiment with advanced language models. And with this, it's a wrap up for our exploration of text generation using Hugging Face transformers. Today we have delved into how parameters like repetition penalty, temperature, top P, and do sample can influence the creativity and coherence of generated text. By adjusting these settings, you can fine-tune the model's output to suit your specific needs. And these are not the only parameters that are here at our disposal. You can check out the documentation page for the generate method on Hugging Face's website to see the full list of parameters which is available to us. And remember that repetition penalty discourages the model to repeat its output over and over again. Temperature controls the randomness of prediction, and top P limits the selection to a subset of probable words, and do sample enables sampling for more varied outputs, and without do sample you can't see the effect of temperature and top P. Experimenting with different combination of these parameters can lead to fascinating results, so don't hesitate to try out various settings and see how the model responds. And you can also try out changing the models itself as well. So if you have any questions or need assistance with your projects, feel free to reach out to us at Codersarts. We are here to help you navigate the world of AI and machine learning. Thank you for joining me in this session. Stay curious, keep experimenting, and see you in the next video where we'll learn more things that we can get done with LLMs.